All right, we should be live now. So, with our next guest, this is Francesca Saki. Uh,
Hello.
she is a master's student at the University of Minnesota, and she specified she, her pronouns earlier when we were talking. So, yes, I believe you have a presentation to share with us. So,
I
by all
do.
means, go ahead.
Great. If I look this way, it's because my screen is over here. But
Hmm.
hi, like it was said, I'm Francesca Saki. I'm at UMN. And first of all, thank you so much for giving me this opportunity to talk about my research and just myself as a scientist. I think this is a really important cause. The most important thing right now, given everything that's happening, is that we create communities and that we share our skills with each other and our voices to help others who are unheard. So, that being said, I will share my talk. So, is it all good? Looks
I can see
like,
it at least. Yep.
yep, cool. All right. So, let me, let's see, make this a little bigger. Okay.
You
So,
could go in presenter view if you want.
yeah.
Yep.
Okay. Cool.
Yep. There
All
we
good.
go. Yep.
All right. So, basically, if you look at this talk, that this first slide, it looks like a typical science talk that you go to. You've got your long title with all the esoteric words. You've got me on it. You've got all the places I'm affiliated with. And it looks like I'm about to talk about my master's thesis, which I was. I was going to talk about just what I'm studying, these amazing animals. But I actually want to make this a bit more of a personal talk because, given what I've seen on the stream, there's a lot of creative artist types of people on here, like myself. I am first and foremost an artist, and I became a scientist. And I just want to show how I was able to do that and how I think incorporating something like art in your daily practice in whatever field you study can really help you have more perspectives and really think deeply about what you study. So, with that in mind, I want to first talk about my earliest inspirations, which were these three main artists from books that I read. And some of you definitely recognize some of these.
Mm-hmm.
James Gurney up here made the famous, amazing book Dinotopia. Which was also a TV show. We're not going to talk about that. I prefer the books. I highly recommend them. And basically, it's this beautiful utopian world with dinosaurs and people interacting in this kind of steampunk esque setting. And he hand draws all of the work himself. William Stout, the pinnacle of the 80s over here, made all these amazing trading cards and still makes all these great graphics of dinosaurs, other sci fi creatures, and really captures intense emotions and moods and gives a lot of life to these animals. And Helen Ward was one of the many artists in the Dragonology book, but hers were usually at the front and center on the pages because she incorporated a lot of texture and color to really bring these dragons to life and make it feel like you could actually see dragons in the world. And I solely believe Helen Ward made me the crazy dragon girl that I am today. And basically, again, constantly when I was drawing at a very young age till now, I was looking at these books and being inspired. And I soon realized that all of these artists actually have something very in common, which is that some of their main inspiration is from science, actually, and from field notes, observational sketches of specimens, published data, basically all these different ways in which scientists would show how they're observing something and form in all of its entirety, whether that's like looking at different anatomical parts or explaining the behavior of something or its symbiotic relationship with a plant, or even just like the map of a geological crater, something like that. But basically, there's a real art to how you explain information and how you show how the world works. And it's clearly inspired these artists. And I think I worked in a kind of backwards way where I found these artists first and then slowly began to wonder how I could also see the world the same way these scientists do. And you can also see that through my art as well. So here's some early art of mine, quite a throwback. Hopefully it's not too blurry, but first of all, dragons everywhere. I just loved their character. I loved how there's, at least according to the Dragonology book, there's a lot of different kinds of dragons on every continent. And I just was obsessed with drawing them, and I still am. But also, I want you to specifically look at these 3 drawings that I did. So what's interesting with these is that I took a specific character, which was this like animal, and then I tried to draw it in a lot of different positions and a lot of different directions, and also just break it down into its basic shapes. And I think that was kind of me at a young age, first drawing similarly to these artists I saw, like James Gurney, where he takes up an entire page to just explain one character. But also, I think in my head, I was just trying to break down and understand how that form like could even come into existence. How do we get something like a cat? How is it constrained by its anatomy or adapted with its anatomy to like cling onto trees and stuff? So yeah, I just was basically thinking and dissecting this way through my art. And I was actually thinking very much like how a scientist might first approach something it's never seen before, or something that it knows very much completely about, and just trying to make all of the connections. But I then realized, though, that I wanted to know more about the actual inner workings of animals and their biology, their evolutionary history. And I realized that to pursue a degree in something like that, such as zoology, would really help me. And maybe hopefully would even help my art go even further than it had before, because I would have this deeper understanding. And that's exactly what I did. I went to undergrad for zoology. And also, I just want to say a side note, if anyone ever has any questions about career development or what it's like to go into a degree like science when you have something like a learning disability like I do, when science isn't something that comes quite naturally to you, like feel free to reach out to me. I have been through a lot. I've transferred schools before. I've volunteered when I couldn't get an internship. Like, it's a hard journey, but if you really set your mind to it, it will happen, and people will like appreciate you even more for it because you've worked so hard. Not to toot my own horn, but yeah, if anyone ever wants to talk about that, I'm more than open to. But anyway, so college was great. It was a little hard at first getting used to the learning curve, but I really blossomed in my upper level courses because I could really focus on specific areas of science that were, especially the highly visual aspects and like abstract aspects of it, that I like naturally got more. So a lot of that involved studying evolution, biological diversity, where I could like look at all these different animals and see how like maybe certain things could obviously be examples of convergence or relatedness. And then of course, like comparative anatomy classes where you're actually hands-on with specimens, like looking at their anatomy. And in that, I got really excited about some of those old, crazy anatomical science drawings that you would see in textbooks, which also inspired me. But yeah, I basically knew that I needed to then, do some form of an internship. And so I just basically contacted the Field Museum because I lived in Chicago, and luckily through some very nice people there and a mentor of mine, Robert Burrows, I was able to work in the J.G. Low lab on a project involving arviculine rodent teeth. Here's a tooth right here, very elaborate looking, and basically you can recognize what type of species or even genus you're looking at of arviculine if you look at the tooth. And this was all, I didn't have any specific interest in rodents. It was just the thing that was available because I was looking for volunteering, but I loved it because it was, first of all, it was a paleontology project that was highly visual, and it used all these modern innovative methods that I had no idea about, such as CT scanning and morphometric analysis, which if any of you read a lot of paleontology papers today, a lot of that is paleontologists are at the forefront of that research. And I loved it because, again, it was like comparative anatomy, but in this like really modern context. I walked into the lab. It's kind of hard to see, but this is the lab we worked in. And it kind of reminded me almost of the like animation studio that my dad worked in, where it's like all this like stuff is just splayed out everywhere on the tables, like all these 3D printed models and all these drawings on the chalkboard. Like it felt like I was in like an art studio or something, but I was in a science lab, and that was just awesome. And then also on top of that, one of the programs that's used a lot, Aviso, which is taking a CT scan. So I didn't explain this, but a CT scan is like this kind of advanced X-ray that you would take of a specimen. And it captures all the surface detail of that specimen, but it also captures the interior anatomy as well. And all of this can be visualized both two-dimensionally and three-dimensionally on a computer. And the program Aviso allows you to visualize these things at once. So here's the like X, Y, and Z planes, and then here's them all together, making the 3D surface. Mm. And automatically I was like, this is like Photoshop. Like there's a magic wand tool, there's a lasso tool. Like I automatically connected to it. And I use my drawing tablet when I work in this program. Like it doesn't, like, I don't want to say it doesn't feel like I'm doing science, because I'm definitely doing science, but it's like, it's art too, to me. So yeah, and just a really quick thing, I also just kept doing other forms of visualization in undergrad, such as some histology on fish ovaries. And then you would like this one. This is a Miocene bird. Yes. So these are embryonic bones of that are encased within a egg from the Miocene. Wow. And it was found at a glacier lake. So it's really interesting, and it's cool. We didn't have to at all penetrate the egg or anything because of CT scanning. So that was really exciting. But yeah, basically, you could say this is really impressive, but also to some scientists, this might seem like all over the like board, like you don't have a specific taxa you focused on or anything. And I like to say that that's okay. There's a lot of time for soul searching in undergrad. And I realized that there was something shared between all these, and that is I needed to work on something that was highly visual data that utilized my visual skills, but also incorporated this idea of how do we get such morphological diversity, specifically within like certain groups of organisms. So what can we learn about that group's history that allowed that access to all the variation we might see in like a genus or an entire clade. So that's what I knew I wanted to do. And that basically was also, first, I want to segue to some of the art I was doing at the same time in college and stuff. Basically, my art, I think, did really benefit from my science. And these aren't like, I did like some more official pieces, but these are just some sketches in my sketchbook. But like say in a lot of my anatomy classes, drawing the anatomical parts themselves also helped me like study certain bones and stuff better. And I noticed too that I wasn't just drawing the basic outlines, but I was also including contour lines to show like actually how curved or how convex something is. And when you're working a lot in 3D programs, that's what you kind of start thinking too, is just how like much curvature or how deep something is. Like it becomes very abstract basically. And yeah, I just started really getting into this more geometrical anatomical drawing, as you can see with like all of these. And yeah, that both of those things, both of my research experience and my art helped me pursue like going down this path to wanting to study this specific group, which is the Geomyoidea. And they include gophers and pocket mice and kangaroo rats. Basically, they include two large families called the heteromyids and geomyids. This is extant animals, not fossils, sorry, but they are endemic to North America and parts of Mexico. And what's interesting is that they are they look very different basically, and they have very different lifestyles. You have heteromyids that live in deserts and eat seeds, and they are various forms of locomotion, from like bipedal jumping up and down kangaroo rats to on all fours, more like saltatorial, like a squirrel, versus gophers are these like robust, heavy duty rodents that mainly stay underground and burrow all the time, and they eat roots. And these two are the most closely related taxa to each other. So it's just a question as to how can we have such a burst and spread of variation between things that are so closely related? Like, how does that even happen? And that incorporates a lot of this new field of visualization that I'm getting into, which is morphometrics, modularity, and integration, and just the and also morphospace. So morphospace is kind of just this idea of you have an object that's like floating in space, and where can it like potentially occupy space? It's really hard to explain. It's a little abstract, but basically before you get into the idea of like comparing things, you have to realize that there's only certain areas of space that something can actually form, or it's constrained away from actually going into that space, and that's because of certain constraints in evolution. Again, very abstract. I think it's fun. And then morphometrics is just a very modern form of comparative anatomy where you're just studying the geometry of shape. You can do it 2-dimensionally or 3-dimensionally. A lot of labs are doing really innovative techniques, such as this fish is a screenshot from the Goswami lab. And they're doing things such as semi-sliding landmarking, which landmarking is just you place landmarks on something and see where they might be in a different spot on another organism. But the semi-sliding landmarks are able to occupy not just that one place you mark, but areas around it. So it's able to capture more 3-dimensional space and more complex shapes. And then lastly, modularity and integration is kind of taking all of these ideas of studying shape and form, but also incorporating function. So, which basically to study the evolution of morphology, you need to not just understand the form, but also the function of it. So basically with modularity, you have different traits, say, I won't say a specific part, but you basically have different traits that co-evolve together, and that's because they serve a purpose together that help that organism adapt in its environment. So that's the simplest way I could explain it. And the amount that those traits are connected is how strongly they are integrated together, if that makes sense. So these are all things I've learned in the past couple years, like less than 2 years. And I think if you asked me a few years ago about this, I would be like, how could I learn all of this so quickly? And I think it's because I go in thinking of this as something that I can, like, from an artist perspective, something I can add to my portfolio, if that makes sense. Like, it's like, these are completely new visuals I've never used before. I've never thought to see things this way before. And it's exciting to find more ways to see the same thing, but in a different light, if that makes sense. And here's some of the visuals I see every day that inspire my art. So here's 2 of the specimens. These are from the Field Museum, but this is Microdipidops. It's one of the genera from the Heteromyia group. They're very ricochetal, so they're bipedal. Here's like one of the skulls right after being CT scanned. Like, you probably can't even recognize what that is right now, but it's the kind of cross-section towards the back of the skull. Here's some more of them all placed together before being scanned. And then here's one of them being 3-dimensionally created into a surface. And this is just a little screenshot from my notebook. I have a notebook with like so many notes of just like random philosophical ideas about my project, and then also just important notes. But then simultaneously, I'm like drawing these skulls, like they just come out of my head and I just draw them. So I'm like equally being inspired artistically and scientifically. And of course, there's a dragon or 2 every once in a while in there. It's never gone.
Yep.
And and then I just wanted to end really quick on a quote by Kara Walker, who's a really great artist. You should check her out. But she basically says that there's no diploma in the world that declares you as an artist. You declare yourself. And just to show that these are 3 examples of the artists I talked to at the very beginning. So basically Ward she made a dinosaurology book that I didn't know about. So we should all go check that out. And then William Stout actually goes to Society of Vertebrate Paleontology every year. Yep. I ran into him last time. He's from my hometown. We're best friends now. He's always wearing a bandana handkerchief thing on his neck. That's how you can tell it's him. And then James Gurney actually collaborated with scientists for the Scientific American in 2016. And this is one of his pieces of Rapenomamus, I believe, which is a badger-like mammal in the Mesozoic. So it's all cool. Like everyone's talking to each other, and that needs to keep happening, or else we're going to talk past each other, and no one wants that. So with that, I just want to say thanks. Here's some random drawing I did, but please donate if you can, and also be active in this movement right now, because we need everybody to be. So thank you so much.
Wonderful. Yeah, that was a wonderful presentation. Thanks a lot.
Hope I didn't take too long.
No, not at all. So we do have a little bit of time left to answer questions. So if anyone has questions about art and science, geomyoids, feel free to send them in, or about learning with a disability, like you mentioned earlier. Please do send them in. Yeah, but yes, what you okay, there's a question without a donation, but since there's no one else asking right now, I might as well read it. I see. They're curious about the bird egg that you showed earlier. So it's where was it found, and has it been published on?
So it's a bird egg from Germany, I believe, and it's actually not published yet. Right. So we're still working on that, and there's a couple of hurdles we have to jump through to help get that more easily published, because it is like a single specimen. It's sometimes harder to do that with just one specimen, but also a lot of the preliminary research is all in Dutch, and the person I worked with, Pete McVicky, he's like, oh, it's in Dutch, it's fine. And it's like, I don't speak that. But yeah, it's a little on the back burner right now, but we're going to, hopefully once we get access back to labs, and it's easier to, because it's a very delicate scan, so it's hard to see through a virtual private network computer. I can't really see the scan that well. I have to be glued to the screen. So when we get access back to the lab, that should be getting back in the works.
Excellent. Yeah, I certainly look forward to it coming out. And evidently some other viewers are curious about that too. But yes, what you said about kind of the interplay between art and science, that's definitely seems to be a big thing. Like you've noted, a lot of people in this community seem to be very creative people, and certainly there's a lot of overlap in the skill sets that can be beneficial in both of those fields. Yeah, a lot of my lab mates who are on the guests on the stream earlier, here in the lab of my supervisor Daniel Field, we actually also work a lot with CT scan data, bird skeletons. And it's true, because I also like to do a bit of digital art in my spare time, and not a very accomplished artist, but still it's something I like to do, and definitely it's doing segmentation of a CT scan is very similar in many ways to working.
Yeah, and I was going to say, I think it's I think also, I don't know about you, but for me, I think I've just gotten more and more interested again in art from the more I work in this kind of thing. And I think it's just there's this innate need to create from what we see. And if that's what you're seeing all the time. And also, I think, I don't think it's a coincidence at all that these two overlap a lot, and that there's a lot of people that are gravitated towards both art and science. I think for so long we've separated the two, but I think they're actually very similar, like how geomyids and heteromyids are really similar. It's all connected, and I think that's the thing too, is I think I think we are very quick to say about ourselves unkind things, oh, I'm not creative, or I'm not a scientist or something. But I think the moment you say that, you lose your potential to do
Right,
those things.
right.
So I think it's important, if you keep telling yourself you can't be creative, you can pretty soon say you can do other things as well. And
Mm, mm.
that's how we stay passionate about a field and pursue it the rest of our lives. So
Absolutely. Yeah, yeah. Very well said. Let's see. Yeah, okay. I think I should go fetch the next guest soon, but thank you so much for being here,
yeah,
Francesca.
thank you, and great job on your part.
Oh, not a problem at all. It's the easy
Have
part.
a good one.
Later. So I will turn the stream off momentarily.